Learn how to add fractions with four easy strategies. In fact, there are only four ways to do it, and we have taken all the four cases in this short video. So, if you were struggling with fraction addition, this is it. This is the end of it. Great. In this lesson, we'll break down four different types of fraction additions to help you master this important concept. Now, what are these four cases? Case one is adding fractions with the same denominators. So that's simple. You don't have to do much. But case two is adding fractions when one denominator is a multiple of the other. And case three is adding fractions with co-prime denominators. And case four is general method using the least common denominator method to add fractions. I hope it makes sense, right? We are going to do all this with the help of examples, and we'll show the result on a number line. We'll also follow the grid model to add so that you learn much more than just these four things which look here. So keep up with this video and understand the key features. I'm Anil Kumar. Welcome to my YouTube channel, a platform for learning absolutely free for the last 15 years. It's all because of your active participation. Keep participating and keep sharing. Let's move on with case one now. So, case one is the simplest of all, where already we have a common denominator, right? So you can see here we have 8s as the common denominator. We have to add 3 by 8 plus 5 by 8. So these fractions, you don't have to think much. So just take the common denominator, which is 8, add the numerators, which is 3 plus 5. In this case, it happens to be 8. Now, once you get the result in the fraction form, it is important to write it in the lowest terms. So in this case, 8 divided by 8 is 1, and that's what you get. Perfect. On a number line, what I've shown you is that both these fractions are less than 1, right? So 3 eighths, this is 3 eighths, and then we have 5 eighths, right? So that is 5 eighths. When you add these two, what you really get is the number 1, which is this particular distance, right? So if you are making strips, right, for a number line, you can actually cut this strip and place it here. And you'll find after 5 eighths, when you put 3 eighths, you will land at 1. So that is a practical way of doing it. So try it out with the other examples so that you have a visual way of checking whether did you get the right answer or not. Makes sense, right? Okay, great. Now, let me also introduce to you the grid model. So, what we do here is I prefer to make rectangles since in rectangles you can easily represent the fractions. So, we are talking about eighths, means I have to divide this whole into 8 equal parts, right? So, this is now half, half of half. So, we got 4. And then this straight line right there gives me 8 equal parts. And then what are we doing? 3 by 8. So color 3 of them, right? So 1, 2, 3, correct. Then 5 by 8. So 1, 2, 3, 4, and the fifth one. What have you done? Well, you colored them all, and so the answer is one whole. You get the whole idea, right? So that is how it should be done. You can use different inks to color and see the result. For example, the first three were kind of like this, right? And rest of the five was. Okay, so you got introduced to our method of doing things, right? So this is how we are going to make it extremely simple. So I hope there are no difficulties, right? So let's move on and take the second case. Remember one thing, if the denominators are already same, do not change them, right? Just add the numerators and move forward, correct? So move forward to case number 2, and where one denominator is a multiple of other, right? For example, 2 and 4. So 4 is 2 times 2, right? 3 and 6, 3 and 9, 3 and 15, like this. So when you have a multiple then it is a very simple case, right? So that is what we are calling case 2. What if one denominator is a multiple of the other? In this case, we convert one fraction to match the larger denominator, right, before adding. So, as you can identify, 4 times 2 is 8. So, 8 is my larger denominator. So, I'll take that. So, I'll convert both 1 over 4 plus 3 over 8. So, what am I going to do? To make it 8, which is now a common denominator, so let me write down that the lowest common multiple of 4 and 8 is what? 4 and 8 lowest common multiple is 8. The larger of the two numbers. You get the whole idea? To make this 8, I'm going to multiply by 2 over 2. 2 over 2 is 1. Multiplying by 1 does not really change your result, right? So we get absolutely same thing, which is 2 over 8 plus 3 over 8, right? And that gives me, now once you get to the stage that you have the same denominators, you don't have to worry. Just put that denominator down, add the numerators, get the result, right? 5 out of 8. So in this case, if you add, you get on the number line 5 out of 8. So cut two strips, one which is 1/4 of the length, the other which is 3 by 8 of the length, put them one after the other, right? So if I put this, right, and then this, which is 1 by 4, you get the whole idea? 3 by 8. Then what you get is the result 5 by 8. Try it out. So, experimenting for our junior and middle school students will be a great practice, and even for teachers to have this kind of a project, right? So, I hope that really helps. So, case 2 is clear. When one of the denominator, we're just keeping it simple now, we are just adding two fractions, and those two are proper fractions which we are adding, okay? So, if one of the denominator is a multiple of the other, then just keep that higher number in the denominator, find equivalent fractions, right? So 2 over 8 and 4 over 8 are what? These are equivalent fractions. Perfect. So once you get equivalent fractions, you can actually add very easily. And let me also show you the grid model, right? So what we had here is adding these fractions. I always start with the rectangle. Rectangle is a very good figure which can be divided into whatever you want. So let me divide it into. We are talking about 1/4. Okay, so let's divide it into four equal parts, half of half, and then 1 out of 4 means you shade one of them, correct? Next time we have to do 3 by 8. Now how do I get 8s, right? So for 8s I have to further divide, and that is what we are looking into. You see, 1/4 became 2/8 immediately, right? And now 3, so we have to shade 3 of them. So let me shade 3 of them. So now you can see how many 8s have been shaded. 5, correct? So that gives us 5 by 8 as the result. You see how beautifully it has been illustrated on the diagram here, right? So it's also called grid model or area model, right? There are two names to it, grid model or area model. Both ways it works perfectly fine. Great. So I hope this is clear. Now, here is case 3, slightly more complicated. So, here when we are taking co-prime denominators. Now, what are co-prime numbers? Like 3 and 2, nothing is common between them. So, co-prime means no common factor, right? Not necessarily prime numbers in the denominator. You get the whole idea, right? So, even if I have 1 over 4, right, plus let's say we have 5 over 9, right? 5, 4, and 9 are also co-prime. They don't have any common factor, right? 4 is 2 times 2, 9 is 3 times 3. They don't have any common factor. So these are also co-prime. So here we'll use the same strategy as we are going to use for a very simple case, 1 over 3 plus 1 over 2, right? So now, what if the denominators have no common factors? We then find the least common denominator by taking the LCM of both the denominators, right? So basically, in this case, you kind of multiply them, right? So it becomes 6. So LCM in this case will be for 3 and 2 is going to be equal to 6, which you get by cross multiplication, right? You see that. So in this case, you do cross multiplication. So let me write down here. This is a very special case when you do cross multiplication. So 3 times 2 is 6, correct? And and then this goes there multiplied. So 2 times 1 is 2 plus 3 over 6. You get the whole idea. So that is how you can very easily get this fraction, right? Equivalent fraction. Now, once you have the common denominators, it's easy. 5, add the numerators, keep the denominator same. Don't add it up, right? So 5 over 6 is your answer. So the next question, I think you can do it yourself. Let's try to do it with the same concept. So here the denominator will be what? 36. 4 times 9. Do you see that? So I'm just writing 36 here. And then cross multiply. 1 times 9 is 9 plus 4 times 5 is 20. And therefore, the answer is 29 over 36. You get the whole idea. So, in case the numbers in the denominator are co-prime, means they have nothing in common, no factor in common in that case. You can cross multiply, get the result. Once again, we're continuing with this strip on a number line which help you to visualize the result. So if you have one to here, you go up to half, and then from here you add another one third, right? So this is half for you, and then you add one third. So a strip of this length is being added here, right? That is addition. Then what you get is the result, which is 5 by 6. 5 by 6, as you can see, is less than 1. And so, very clearly, we have 1 here, right? So, you have something 1/6 left. You see that? 1/6 left. In the area model or the grid model, what you can do is make a rectangle. Just make a rectangle here. And what do we need? We need one third and half, right? So you could divide this into three equal parts, for example, and then you shade one of them, one third. So we are adding what? We are adding one third and a half, right? So you do this. Okay, so one third was easy, and half of it. How do you do half of it? For that, one thing could have been that you do it kind of divide like this. Correct. Now we get 1, 2, 3, 4, 5, 6 squares, and half of them will be 3. So we'll shade 3 of them. You see this 3 shaded? As soon as you do that, you can now get your answer, which is 5/6, since each is 1/6. That is the grid model or the area model adopted to show addition of fractions as clearly as it has been done. So, number line, where we are actually cutting the strips, and it's a practical way of showing it to the students, right? Okay, great. So, we've done 3 cases. Now, 3, I have taken this as a very simple example. I'll take another one, and there's a clear difference between the two. So once again, we have the same numbers in the denominator 3 and 2, which you know are co-prime. So what strategy are you going to adopt? Well, cross multiply, right? So we can say, right, common denominator is 3 times 2 is 6. Do you see that? So how do you get this 3 times 2 is 6? You get the whole idea, right? So that is the number. And here what you get, 2 times 2 is 4, right? So let me write 2 times 2 plus 1 times 3, right? Okay. So we have 4 plus 3 over 6, which actually is 7 over 6. So it is more than 1. As you can see in the result, we have here 7 over 6, correct? More than 1, right? Now, uh, so you can have a strip which is half long and then two-thirds long, cut them, place them one after the other to get the result. That's one part. Second, which we are also continuing with, is how do we show it on an area model? Okay, so that's the part. Now, since we have to represent something which has been divided into three equal parts and two equal parts, so how do we do that? So what we do is that we make a rectangle, perfectly fine, and divide it into three parts first, right? And then we also need half, right? So half. So as soon as you do that, you can very clearly see that we are getting 6 squares, which is the common denominator. Correct. And now, since we have the 6 steps, one of them we have to shade 4 of them, right? So let's shade 4 of them. We shaded 4. How about 3? Now, when you start shading for 3, right, then what happens? You got 1, correct? You got 2. Where is the third one? So for that, you need another rectangle. You get the whole idea, which is exactly same as the previous one. And now you can shade one more. So now you see you got one whole and 1/6. You see that? And that is your result 7 over 6, which can also be written as 1 whole and 1/6. So it is same as 7 over 6. You understand? So that is how it should be represented, and that's why we took case 3b, where even co-prime numbers, we could have this kind of a situation. So in this case, the sum is an improper fraction, 7 over 6, which means it's slightly more than 1, as you can appreciate on the number line. Makes sense, right? So that's how we are working on. We have another case, case 4 to go. I hope you're liking this particular way. And if that's the case, like and subscribe to our videos and also provide suggestions to us. Great. So now let's move on to case 4. In case 4 also, we'll have two cases. Perfect. Now here, common factors in denominator. So last time it was co-prime, there were no common factors. Now this time we are having a situation where there are common factors. Let's try to understand this. For example, 6 and 4, right? As you can see, 6 is what? 6 is 2 times 3, right? And what is 4? 4 is 2 times 2. So they have a common factor 2 in it. So when you want lowest common denominator, then this has to be factored out, right? Now, let's see the LCM model, right? So let's talk about LCM, right? So LCM situation is 6. 6 means we got the numbers like 6, 12, multiples as 6, 12, 18. And for 4, we have 4, right? 8, and then 12. As soon as you hit 12, you know we have a common multiple. The lowest one is 12, and it is not 6 times 424, right? So, since it is having a common factor of 2, the lowest common denominator is not cross multiplication. It is not 24. It is half of 24, which is 12, correct? So basically, now we know that the LCM in this case is what? So LCM is actually equal to 12. So you have to rewrite this as something over 12. You understand? So from 6, you have to multiply by 2's. So 2 times 1 is 2. And this 4 times 3 is 12, so multiply by 3, correct? So you get 9 here. And adding 9 and 2 is 11, and the answer is 11 over 12, which is slightly less than 1 on your number line. So when you cut this strip, right, add on 3, 4, if you add another 1, 6, you will reach 11 by 12, slightly less than 1. That shows the result, correct? Area model. So 6 and 4 means, let's say, so we have this particular thing there. Okay, great. So we will divide this into 6 parts. So you have, let's say, half of it, right? And then 3 more, right? 1, 2, 3, 1, 2, 3. So these are 6 parts, correct? And then 4 parts. So you don't really have to do 4 parts. It will make it 24. You only want half of it to make it 12. You get the idea. So that is the lowest common multiple. So don't go for 24. This is enough. Let's see how it is enough. So, so out of this, 1/6, if I say 1 out of 6, then these were my 1 out of 6, correct? Now, 3 out of 4, 3 out of every 4 also means 9 out of 12. So it's easy to do 9 out of 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, and 9. You see that? One left. So it is 11 twelfth, 1/12 left. Makes sense. So this is 11 out of 12. So that is how you could do it. Perfect. I hope that's absolutely clear. Now, getting to the last case, which is case 4b, right? So the idea here is for you to also attempt and do it. So the question is 7 over 10 plus 5 over 6. So how should we do it? Clearly, the denominators 10 and 6 have something in common. Both are even numbers, right? So, so let's find the lowest common denominator for this, right? So the idea here is to write down the multiples of both 6 and 2. There's a couple of ways to do it. So if I do 6, then it is 6, 12, 18, 24, 30, 36. 10, easy 10, 20, 30. So as soon as we hit 30, we know we have reached the lowest common denominator, which should be 30. Is that clear to you, right? It is not 60 once again. Why it is not 60? Because 10 is 2 times 5 and 6 is also having 2 as a factor. So so if you directly multiply, you are using 2 twice. So half of that should be your result as lowest common multiple. This is a very important concept which you can see and apply directly and avoid these writing multiples, right? I want you to avoid this. Great. So we have 30 as our common denominator, right? So to make this 30, I have to multiply this by 3 out of 3. So 3 times 7, 21, and here by 5. So 5 times 6 is 30, and 5 times 5 is 25. So adding 21 and 25 gives me 46 over 30. Now once again, 46 over 30 is, is a big number, and what we need to do is to simplify this, right? So first thing is simplify this. So it becomes half. You can divide both by 2, right? So it is 23 over 15, right? So 23 over 15. Now for most examples, it is slightly more than 1, as you can see the result here, 23 over 15. So you divide and find improper fraction, right? So 23 is what? 15 plus how much is 23? 15 plus how much is 23? 5 will give me 20 and 3, 8. So 15 plus 8 is 23. You get the whole idea. So basically, it is 1 whole and 8 out of 15. So that's an easy way of doing it, right? So it is 1 whole plus 8 out of 15, right? Which is 1 8 over 15. So you get this as mixed number. So many times you may have to write it as a mixed number, and here before you is a very beautiful strategy of not actually dividing but splitting the numerator and getting the answer. It's a great technique. Okay, so that's how you should be adding the fractions, right? So we've done all the four cases. What is the takeaway from this? Correct? Can you tell me? Right? So, what is the takeaway? So, adding fractions the right way, we need to understand if we have same denominators, in that case, just add the numerators. Nothing is required. And the idea is always to get the same denominator so that you can add the numerators, correct? If it's already given to you, be happy. Just do it and go forward. Great. Now, second case is one denominator is a multiple, right? So, convert to smaller fractions, but use the denominator of the higher number, right? Like 4 and 8, you would take 8 as the common denominator. If you have co-prime denominators, in that case, the strategy is cross multiply. Because they are co-prime, there are no common factors between the two denominators. If they have different denominators, then you find the LCD before adding. Now, this fourth process, finding the lowest common denominator, is actually the standard way of adding fractions. The first three are special cases, correct? So, even if when we are adding more than two fractions, what you need to do is actually you're working with different denominators, you need to find the lowest common denominator and then do it. You get the whole idea, right? Now, I hope you're ready to tackle any fraction addition problems, right? Keep practicing, And always check your denominators before adding. Aha, that makes it right. Like and subscribe to my videos and provide your suggestions. Share and learn. Thank you and all the best.